everyone. Thank you very much for coming. And I know it's like, I think last push, last 2 sessions on Friday. Let's do this. I believe in us. Everything will go smoothly. So I don't have a lot of slides, and I have some demos. So really want to get to demos, but kind of like also give you an overview and just show you what's out there. So basically, we're entering a new era where generative AI is just a commodity. It's not something like expensive or like where you need to train things from scratch. It's available, and you can start using it right now for your applications for different type of tasks, like from augmented workflows where you need to solve day-to-day tasks to core product where you can sell it to customers, or as a support tool which can optimize your internal processes. So a bit of housekeeping. So here's the agenda. Basically, I will highlight challenges with hosting large language models right now and different options for hosting large language models on AWS, compare cost and duration, and show 2 demos. Here's the QR code with slides. I have my internal KPI. I try to minimize how much time people take photos of my slides. So if you want to take a photo of my slide, this is the time to get the link. But also, my session will be recorded, so it will be available on AWS Community Day YouTube channel. So let's take a look at the usual data science process. So usually it's pretty straightforward. So we start with business understanding, then we get data, then we decide on the model, we train the model, we deploy the model, and get feedback from customers. But in reality, it's a very iterative process, and we actually want to get customer feedback as early as possible in our pipeline, and based on it, maybe update the model or data and so on. So for this, we need to be sure that our infrastructure is flexible, that we can start early, and we can easily integrate our machine learning infrastructure with production infrastructure. So if we look at the usual large language model application, we will see that it consists of multiple parts. So basically, we have a data pipeline on the top side. Basically, we have ways to create this RAG application, basically where we need to populate a vector database with context, which we then want to provide to generative AI model. And on the bottom side, we can see that we host the app, we orchestrate requests and vector database and so on, and we make calls to LLM API. So in my talk specifically, I will focus on these 2 parts, basically where we host the model themselves, not the database, not orchestration, just pure models. So with usual machine learning models, we have certain challenges that because it has to work in production, we have production requirements like latency, load, and cost. It has to scale because most of the time we have peak loads every time we interact with ML, more or less. And we need to be able to integrate with existing infrastructure. For LLM models, now we have 2 more challenges. So we have high memory usage, because large language models, and usually specific inference frameworks. So your usual inference frameworks like Onyx may work or may not work, but usually you need to kind of have specified container image and other stuff for large language models. So if we look at the usual inference stack for large language models, it basically from model to code, container, and hardware, we can see how it's different from usual machine learning inference. So starting from model, which we can store as part of container image, or we can store it on S3 or some other registry, private, jumpstart, or Hugging Face. LLM itself, model can be different depending on using open source model from Meta, using some private model, maybe you apply some optimizations, maybe you fine-tune model to suit your needs. Next is code. The simplest way if you don't need to manage any code at all, where you have just API with the model and that's it. Otherwise, you need to manage code for inference itself, usually low-level optimizations and model management in case you have multiple models. For container, that part can usually be abstracted from model inference, but part of the container is libraries and frameworks for inference. So among popular ones, things like VLLM, TGI by Hugging Face, Llama CPP, and so on, and corresponding base image and packages. And finally, hardware. Like, things I want to highlight here is basically that you always need to balance speed, cost, and scale. I will share like specific numbers later. You could use both GPU and CPU for LLM. Like, usually people use GPU because like they focus specifically on the speed part. But it could be the case where like CPU with CPU-related optimizations can work for your case. So now the inference stack which I just showed, like if we put it and compare among different options for hosting the model, like we can see basically where like there are most serverless options on the right where you don't need to manage stuff, and there are less serverless options on the left where like you have to manage more stuff in purple. The main advantage of like the SageMaker estimators, so custom container, estimator, and Jumpstart, is that they deploy basically the same endpoint and it's the same SDK. So if you want to switch between them, it's actually pretty simple. So now let's take a look at each of the options. So first let's take a look at different options, and then I will show you how we can deploy the same model, Llama 8B, Llama 3 8B, using different options. So SageMaker Inference endpoint, that's pretty standard way to host any machine learning model using SageMaker. Basically, it can be deployed from SageMaker SDK. You can customize number of instances or instance type. Load balancing is handled by SageMaker, which is nice, because usually managing load balancing is hard. And you can deploy inference in multiple ways. It could be real-time, it could be asynchronous, batch, transform, or serverless. So next option is Jumpstart. Jumpstart is basically a catalog of different models which you can do, where you can do deployment with one click. I will show you later during demo how it works, where you can basically just select the model, one click it, and you have working model in your account. And basically, yeah, with foundational models, something you can also do is deploy it using SageMaker SDK. There, basically, it becomes very simple. You just need to reference model ID, and that's it. Next option is to use Hugging Face Estimator. That's basically a custom Hugging Face estimator for SageMaker, which increases number of lines, I would say, a bit, like maybe 2 more lines, but you can reference any Hugging Face repo. And in case, let's say you found some interesting model on Hugging Face and you want to deploy it into your AWS account, it's very easy, assuming it works with Transformers library or TGI, I think. So let's now take a look how the deployment would look like for Llama 3. So first option, Jumpstart, literally 3 lines. You import library, you select model ID, and you deploy, and you see that basically you just select instance type which you need. That's it. After that, you have a working endpoint. Second option, Hugging Face. Now we're referencing Llama 8B from Meta's repo on Hugging Face. So we just need to provide model ID, so it's like GitHub repo, there is Hugging Face repo. And although like we need to get like image URI like to deploy it, but you can see that for predictor, it's the same thing. We just need to select instance type, and that's it. And finally, let's say I want to have my own Docker image. I want to have like my own model. SageMaker will support that as well. So in this case, basically, I just need to define model using my custom Docker image and reference model data, and I can deploy it in the same way, and I will get the same endpoint. So in case my production infrastructure references endpoint, I can easily replace it, and I can decide on level of customization I need. Let's take a look at other options, which I outlined. So first is Bedrock, which a lot of people shared today. Basically, it's a managed service for foundational model. You don't need to care about servers at all. You don't need to have any servers. You pay per tokens. Or you can have provisioned throughput. In this case, you kind of start caring a bit about some servers, but you don't need to handle them. And it can support models from different providers. Open source, like Meta, or private, like Anthropic. And you can fine-tune your own model based on your data and deploy it using provision throughput. And really good stuff here is that compared to other options, it includes some additional, I would say, nice additions which make it easier to develop GenAI applications like guardrails, knowledge bases, and agents, which make it easier for you to make sure that your application doesn't produce harmful content, or that it's not hacked, and so on. So here's an example to use the same Llama 3. Well, it's not 8B, it's 405B. Like hosting the same model would require like deploying a pretty hefty instance. And in this case, you can just reference it, and that's it. And you can start using it. So next option is basically having your own ECS cluster. In this case, basically, you don't use any SageMaker or Bedrock. It's the option where you kind of manage everything besides hardware itself. So similar to Kubernetes. And you kind of need to manage the whole thing. One advantage here is like basically it's a bit cheaper. I will show pricing later. Another thing to keep in mind, like you can use AWS Copilot, which is framework to deploy and manage clusters on AWS. Downside, it only supports Fargate, which is only CPU. But on the plus side, it will manage the whole complexity for you. So it will deploy load balancer, it will deploy like ECS, auto-scaling group, and so on. And finally, AWS Lambda. So previously, I shared like, okay, can you actually use like CPU for LLMs? For some LLMs, like which are optimized for CPU, you could. And for machine learning models, a lot of people are using Lambda. For LLMs, right now, there is a challenge with like cold start. And like, yeah, everyone says like cold start, Lambdas, yes. But here it's even worse. Like it's like can take minutes to start model. Snap start can help, but it's limited to using Java and zip packages, which I'll show you later. But it can be deployed really easily, and there is not a lot of complexity compared to ECS. In case with Snapstart, what Snapstart does is basically can save the state of Lambda when the model is initialized. So it can work really well for cases like with Onyx Inference, so for traditional machine learning, traditional deep learning models. For large language models, that may be possible if you can adapt it for your use case, but there are two challenges: that it only works with Java, and it's subject to 250 megabyte package limit. So now we looked through different options. Now let's get back to the diagram. And basically here, it was a high-level overview. But let's look at more specifics. So basically, different options mean that we have different limitations in terms of like RAM, CPU, whether GPU is available for this option or not, whether we can use any framework we want or it's limited to specific framework, and how the cost structure looks like. Basically, is it per instance like with SageMaker usually, or with ECS you pay separately for EC2 and load balancer, for example. So here is like basically mostly high-level view. Things to note here is that basically ECS on Fargate and Lambda limited to CPU. SageMaker and ECS use the same type of instances. So if you can use one for your use case, you can use another for your use case. And as you can see with Bedrock, you don't need to care about anything like hardware related. You just pay per tokens. So now let's do cost comparison. So first let's compare like APIs, kind of, where you don't need to host instance and you pay for pure tokens. So usually the payment structure looks like you pay per input tokens, you pay per output tokens. You can see different options here, including OpenAI, even the new O1, which they released yesterday, which is pretty expensive, $15, but it can reason and solve math and physics. Yeah, for those who tried. Okay, some things to note here. First, as you can see, for both OpenAI and Bedrock, there are options to use batch inference, where like instead of real time. So if your use case supports that, that's a way to save money. For example, if you generate reports based like using generative AI. Another thing to keep in mind is basically like the better model means it's more expensive, so it can be like 10 times more expensive per token. So you really want to understand, does your task require that amount of like that complex model? It's one thing. And second thing, the motivation for RAG, basically. If you want to, like each model also has limitation in terms of like prompt size and context size. So if for your model to work well, you need to pass a large prompt, let's say your whole code base, then basically it can become pretty expensive. And that means that you need to apply some optimizations to either have smaller prompt or use fine-tuned model. So that goes back to the question of using like CPU versus GPU for LLM. Like certain models can be optimized like through different optimizations for CPU. So first parameter to keep in mind is number like of parameters and precision. So when people say 8B, Llama 8B, it's 8 billion parameters. Some frameworks are optimized for CPU like Llama CPP. And certain model optimizations which can be applied are like quantization, reducing precision. So reduces size, improves speed. Also, you have a bit degraded performance. Pruning and knowledge distillation, where like using the large model, folks train smaller model. So there are two projects which basically play with that. But it really depends on your use case, because you sacrifice performance a lot. And like it's definitely not only works for cases where like you generate very specific report or like it's very specific use case. The problem with using like, so here we can compare different CPU, GPU options for running, in this case it's Mistral 7B, because it's currently I think like one of the best smaller performing models. Things to note here. Obviously, like there is a cost per month, and for CPU, cost per month is smaller than for GPU. Who would have guessed? But thing to keep in mind here is that because like kind of like if you keep mental model of like that, you kind of pay per token always. For GPU, it can be cheaper per token just because it's significantly faster. And for example, if you have if you have fine-tuned model which can work asynchronously, maybe just starting machine, running your workload, and then terminating the machine would work better for your use case. Second thing to note here is that using custom hardware options like Inference could be beneficial, because like not only it can work faster. So Inference is a custom hardware made by AWS for machine learning workloads. And it works for large language models. And Hugging Face released, like I think together with Hugging Face, they made like inference framework called, I want to say Optimum, which is used basically to deploy models which are compatible, I think, with TGI on Inference. Check out the link. So basically, not only Inference instance is cheaper, it's also cheaper per token when you deploy your model, and usually it's more available if you're using spot instances. But you may need to adapt your model for Inference. And final point, you see that there is G5 2x large and ML.G5.2x large. It's the same instance type, just like the second one is deployed to SageMaker. That's the difference you pay. Like I think basically 10 or 20% addition if you deploy using SageMaker. So basically, in this case, if you start with SageMaker and move to ECS, you can save around this amount of money. So if we put all of these options on the axis, basically, we can, on the left side, we have more control over scaling and lower level stack. On the right, we have easy to start with pre-trained model. So basically, it really depends on your use case. So there is no single answer. But usually, like, you want to start with something right away where you can get very early user feedback. So starting with Bedrock would be very simple. Like, you just use model and you can make requests right away. Then, depending on whether you need custom model, and then you can use a Hugging Face estimator, or you want to fine-tune model, you can host it using a custom Docker container. And then if you decide that, OK, you have sufficient usage which would justify having custom infrastructure, then you could switch to ECS or EKS for hosting your model. But again, that depends on like how the requirements for your machine learning model change over time. So you see here that on a diagram before Lambda was missed. Sadly, not there yet. It's just like prohibitive from cold start perspective and cost per token perspective. So now I think we have 4 minutes left. OK, demos. OK, let me try to do it as quick as I can. So first is Jumpstart. Just to show you how easy it is, like here's our standard AWS console. Next is basically SageMaker Studio. From SageMaker Studio, like if you go to Jumpstart, it will show you, you can get meta, you can select model, and you can decide to deploy it here. I have pre-deployed model just in case. And you can see that I can start sending requests already to it and get responses. So it's something where you can deploy with one click without managing any infrastructure. And you can start sending requests and integrate it with your existing application. Just one thing to capture here is that from Hugging Face, you can already deploy to SageMaker. And there are multiple options. So SageMaker SDK, which I mentioned, Jumpstart, Inference, using the framework which I mentioned as well. OK, now let's switch to another option, AWS Copilot. So basically, it's a way to deploy ECS cluster. So here I want just to show you the running cluster which I already deployed from command line. So you can see that basically it deployed this service and it took 500 seconds, which is kind of a lot. But it managed the whole infrastructure stack for me and just returned me endpoint, which I then can call with a standard prompt, and it will give me response. And here, basically, the ECS cluster, and you can check one of the links I shared before. It will have basically the link to the repo and example. OK, so here's the link to the demo. So to summarize, AWS has a lot of options to start with deploying large language models with different levels of customization. Bedrock is easier to start, but SageMaker enables you to evolve your ML infrastructure depending on your needs. And yeah, feel free to ask me any questions, email I shared earlier. Curious about different use cases and can share more examples and benchmarks. And here are the links to different blog posts and demos. And yeah, thank you very much for your time. Happy to answer any of your questions. And here's the QR code with a link to the slides.
We have time for one great question. All right, since you're right here in front.
So I'm curious, what am I correct in seeing that if I wanted to run like as serverless as possible GPU custom models, is it the ECS with EC2?
SageMaker will be there because you don't need to manage cluster level. You mean like the serverless option will be SageMaker in this case because you don't manage load balancer, you don't manage scaling.
So it'll scale.
Yeah, you can define scaling rules there.
OK, thank you.
Great question.
So we saw provision throughput on Bedrock is expensive, frankly, right?
Oh.
Like, when do you recommend that over moving to SageMaker or one of the other more infrastructure-based options beyond Bedrock?
So if you don't use, like, if you're just deploying your model and you wouldn't expect to have high usage, Bedrock is obviously like no-brainer because like you pay per tokens. But if you expect that, okay, you will have large usage, then you would want to use SageMaker. Asterisk, like it could be cheaper if you decide to use asynchronous predictions. If you don't care about real time, then using cluster could be easier because like you don't pay for idle time by nature.
Thank you.
All right. Thank you. Let's